Today we're going to tackle one of the biggest mysteries out there, Flight MH370. But we're not just going to talk about the disappearance itself. We're going deep, literally, to look at the insane, almost sci-fi tech they're using to search for it at the very bottom of the ocean.
All right, let's start with something you can probably relate to. Picture this, you're out on a boat and, oops, your phone slips out of your hand and sinks into a dark, muddy lake. You can't see a thing down there. So how on earth would you even start looking for it? I mean, really, what's your first move? Okay, now let's blow that problem up. I mean, way, way up. Forget your phone. Now imagine it's a 200-ton airplane. And that muddy lake? Try the deepest, darkest part of the Indian Ocean. That's the mind-boggling challenge we're talking about here. And it's exactly why you need some of the most incredible technology ever invented to even have a chance.
So, when you can't use your eyes, where do you even begin? Well, you have to learn to hear underwater. This is the basic tool, the first piece of our deep-sea detective kit.
And the idea behind it is actually super simple. Imagine you're in a cave and you shout, "Hello!" A second later, you hear that echo come bouncing back. Just from that sound, you can tell a lot, right? Like how far away the wall is, maybe even get a sense of its shape.
Well, that's pretty much exactly how sonar works. A machine sends out a sound, a ping, and then it just listens. It's waiting for that ping to hit something and bounce back. If the echo comes back fast, the object is close. If it's a really sharp, strong echo, maybe that's something hard, like metal, not just soft mud. See? Every single echo is a piece of the puzzle.
And you've actually run into this tech in everyday life, probably without even thinking about it. It's how dolphins find their way around and hunt in pitch-black water. And it's the exact same idea behind the reverse sensor in your car, the one that starts beeping like crazy when you get too close to the wall. It's all about sending out a sound and figuring out what the echo is telling you.
Okay, but just hearing a single ping isn't going to cut it when you're searching a massive area. You need to do more than just listen. You need to start drawing the ocean floor. This is the big upgrade.
So think of it like this. It's basically a giant document scanner, but for the bottom of the ocean. Seriously, this thing, called side-scan sonar, gets pulled through the water and it scans the seabed strip by strip, but instead of using light, it uses sound to build an incredibly detailed picture of what's down there. But even that has its limits. When the stakes are this high, you need the absolute best of the best. And that brings us to something called synthetic-aperture sonar, or SAS. I mean, listen to this quote. People in the know call it the best weapon we have today, the technology that gives the most hope. That's a huge deal.
So how does this super camera for the ocean work? It's genius, really. Think about when you take a panorama photo on your phone. You don't just snap one shot, right? You sweep your phone across, and it takes a whole bunch of pictures and then stitches them all together into one big, super sharp image. SAS does the exact same thing, but with sound pings. It scans an area over and over from different angles, collects all that data, and then digitally stitches it all together to create one ridiculously high-resolution image. It's so sharp it can spot tiny little details that other sonars would just completely miss.
And get this, all of this amazing tech has to work at insane depths. We're talking 6,000 meters. That's almost 20,000 feet straight down. The pressure down there would crush a person instantly, and it is completely, totally dark. Obviously, no human can go there, so who's going to carry all this gear to the bottom of the ocean?
Well, that's where the elite robot squad comes in. And I'm not kidding. These aren't just regular machines. They're super advanced robots, built to survive in one of the harshest environments on our entire planet.
Okay, so there are two main players on this robot team. First, you've got the AUV, the Autonomous Underwater Vehicle. Think of this one as the Scout. It's basically a robot vacuum for the ocean floor. You give it a mission, let it go, and it works all by itself for hours, scanning huge areas. Then you've got the ROV, the Remotely Operated Vehicle. This is the Inspector. This one is connected to the ship by a long cable, and a human pilot drives it, kind of like playing a video game. You don't use the ROV to search, you send it down to get a real good look at something interesting the AUV has already found.
All right, so we've got the high-tech guys and the robot divers. Now let's talk about the complete search strategy, how you put all these pieces together to actually get the job done.
But wait, there's one more tricky problem. After all this time, wreckage could easily be buried under a layer of sand or mud. And your normal sonar? It can't see through that stuff. So what do? You need something like an X-ray, but for the seafloor.
So here it is, the whole search plan, broken down into 4 steps. Step 1, scan. The AUVs go out and patrol a massive area, using that super-powered SAS to map everything. Step 2, Identify. Back on the ship, analysts look at these maps, flagging anything that looks weird or out of place. Step 3. Verify. Once they find a target, they send the ROV down to get an up-close video. And finally, Step 4. X-ray. If they still can't see anything, they bring out that special sub-bottom profiler to check if the debris is buried under the mud. It's a complete system.
So let's just do a quick recap of this high-tech detective kit. You've got the AUV, which gives them the incredible range to cover huge distances. You've got the SAS, which is like having ultra-high-resolution eyes to spot tiny, unnatural shapes. And then you have the sub-bottom profiler, which lets them see stuff that's completely hidden. Every single one of these tools is absolutely crucial.
So there you have it. The technology is ready to go. We have these amazing robot scouts, these inspectors, all armed with what is basically super-powered hearing and vision. The tech has never been better. Which leaves us with the one big question, right? The one that really matters. With all this incredible gear and a solid plan, are we finally going to find the answer that's been waiting at the bottom of the ocean all this time?